Hello friends, welcome to DentLect, the online free dental lecture series. Today's session will be on X-ray machine and how the X-rays are produced from the machine. The major parts of an iopa machine is the control panel, which is plugged into the current socket, and you have an extension arm which connects the control panel and the tube head. And inside the tube head are various parts which I will be discussing in the next slides. The tube head is a metallic framework which holds the coolage tube within it, and it has a aiming cylinder from which the X-rays that are produced in the coolage tube exits the tube head. Now let us see the parts of a coolage tube. A coolage tube is a vacuumated borosilicate glass tube. It has a cathode end which is negative, has a tungsten coil embedded in a molybdenum cup, and the positive end, which is the anode, it is made up of tungsten target and it is embedded in a copper stem. A lot of heat is produced in the process and an insulating oil is used to dissipate the heat. Before the X-rays exit from the coolage tube, it is filtered using aluminium filters and the beam is collimated with a lead collimator. Now let me tell you how X-rays are produced. The power supply that we get in the plug point is a 220 volts alternating current. There are two transformers in the iopa machine. The first one is a filament transformer which reduces this incoming voltage into about 10 volts in the filament circuit. And then there is an auto transformer which boosts this 10 voltage of power into 60,000 to 1 lakh volts, which is required to heat up the cathode to produce the electrons. An electron cloud is formed in the tungsten filament on the cathode. Cathode being negative, the electrons tend to get repelled and it moves towards the positively charged anode, and it hits at a particular point which is called as the focal spot. In basic physics, a moving object is said to possess kinetic energy. Here the moving electrons possess kinetic energy, and when it is stopped at the anode, it is converted into photons which exits through the aiming cylinder. Let us see the significance of each part. Why do they use a vacuum tube? The X-ray tube is evacuated to prevent collision of fast-moving electrons with gas molecules, because this can significantly reduce their speed. The vacuum also prevents the burnout of the filament. Why is tungsten the ideal target material? Number one, it has a high atomic number, meaning it has a lot of electrons, which is most efficient in producing X-ray. Second, it has high melting point. As I've already mentioned, high amount of heat is produced in the process, so it prevents melting of the filament. Number three, it has high thermal conductivity, so it readily dissipates the heat into the copper stem. And finally, it has low vapor pressure, and at high temperatures it helps to maintain the vacuum in the tube. Next, what are the methods of heat dissipation? The first is the insulating oil which goes around the coolage tube. Second is focal spot. Focal spot is the area on the target from which the X-rays are produced. However, the heat generated on the target area becomes greater as the focal spot decreases in size. So, if the actual focal spot is maintained between 1 into 3 mm, then the heat is getting dissipated. And the third method is by using a rotating anode rather than a stationary anode. When the anode rotates, then the electrons strike at successive areas of the target, and thereby it causes widening of the focal spot, and the heat distribution is over an extended area. What is the purpose of filtration? A filter preferentially removes only low energy photons and allows the high energy photons from the beam. Only this high energy photons will contribute to the final image. There are two types of filters, the inherent filtration and the added filtration, and the sum of these two is the total filtration. So for inherent filtration, you have materials such as the glass wall of the X-ray tube, the insulating oil that surrounds the glass tube, and the barrier material which prevents the oil from escaping. However, the added filtration is nothing but the aluminium disc which is placed over the port in the head of the X-ray machine. Next, what is collimation? A collimator is nothing but a metallic barrier made of lead which has a small opening in the center, and it restricts the size of the beam and thereby the volume of the tissue radiated. The collimator can be either a round collimator or a rectangular collimator. The X-rays are produced by two mechanisms in the Coolidge tube. It's the Bremsstrahlung radiation or the characteristic radiation. In Bremsstrahlung radiation, there is a incident of high energy electron which strikes on the nucleus and releases a Bremsstrahlung photon of maximal energy. In case of near-miss interaction, the incident of the high energy electron nearly misses the nucleus and it creates a Bremsstrahlung photon of lower energy. And this Bremsstrahlung radiation contributes to the major fraction of photons in the final X-ray beam. There is another radiation which is the characteristic radiation when an incident electron ejects or removes the electron from the innermost orbital shell which is the K shell. When this happens, then an electron from an outer orbit quickly comes and fills the void in the inner orbit. That is, from the L shell, it gets filled into the K shell. And when this happens, a photon is emitted with the energy equivalent to the differences in the binding energy of the two orbits. And this is the characteristic radiation. So friends, I hope you understood the concept. If you have any doubts or you want me to take a particular topic, then do mention on the comment section below. Thank you.